All right, so this is our first lecture for the muscular system. This would go in your notebook, and it's the beginning of the chapter up to the first set of quick check questions. As usual, I don't remember if your textbook goes through the functions of the muscular system, but my lecture starts off with the muscular system functions. So here we go. So most of us think right away of the muscular system as being associated with movement, but it actually does a whole lot more than that, right? And we're listening in with 100% of our brain, not being distracted by anything else like movies on our phones. Okay, so you're going to see in my lecture notes, I have things underlined, I have things in bold. Those are the key things that you're going to want to write down, okay? So we have 3 types of muscle. Can you remember what the 3 types of muscle tissue are? 3 types of muscular tissue. Okay, one muscle type is connected to your bones, and so we call it skeletal muscle. Oh, Lordy, it's been a long time since we did histology. Cardiac muscle is associated with which organ? The heart. And then we have the third muscle type, which is associated with our body organs, our hollow body organs. So we have skeletal, and I need to make that white, don't I? Let's see. Let's erase that S there and go to white here so it stands out. So we have skeletal muscle, cardiac muscle, and smooth muscle. Okay? Skeletal muscle is connected to our bones and allows for movement. Cardiac is only found in the heart. Oh, that's a horrible looking heart there. Sorry, you guys. Heart. And then smooth muscle. This is associated with all hollow organs in our body. Okay, so this would be like hollow organs like your stomach, like the bladder, like the trachea, like the uterus. Okay? All of those hollow organs are lined with smooth muscle, okay? The only place we find cardiac muscle is the heart, and then we find skeletal muscle connected to our bones. So when we think of muscle in our body, we're typically thinking of which type? Immediately comes to mind when we talk about muscle. Skeletal, right? But really, we can't survive without cardiac or smooth muscle. We have to have all 3 of these types. And they're different from each other, not only in location, but also in their microscopic structure and what they do for our body, our functions, okay? So, muscle cells, we call them specifically, they have a specific name, which is called a muscle fiber. And they can only do one thing. And that is to shorten or to pull. And that's how movement is achieved, is by that shortening of our muscle fibers, which we also recognize as being contraction. Where do we get the energy? Well, that's from what we eat. We get the energy to contract our muscles, okay, from the food that we eat, which gets broken down into glucose. Okay. And that glucose goes through that process of cellular respiration in the mitochondria. And we make ATP. So we're taking chemical energy in the form of the chemical bonds, chemical bond energy, and we're converting that into mechanical energy, which is the energy of movement. And I'm so sorry that the screen is so low up there and I have stuff on the desk right now that's kind of blocking your view. All right, so that is the main, the main thing that you guys are going to think of when you're looking at the functions of the muscular system is movement. Okay, another function. Well, we're still on movement, sorry. Forgot. This one's on movement too. So, insertion versus origin. Okay, these two words, insertion and origin. Probably don't know what those mean yet. But when we have skeletal muscle attached to bones, it's going to be pulling the insertion bone closer to the origin bone. So what's the difference? Okay, the insertion bone is the bone where the movement occurs. Okay, and the origin and it's really not the bone. It's a misstatement for me to say it's the bone. It's the, it's not the bone, it's the end of the muscle, actually. Okay? The end of the muscle attached to the bone where movement is occurring. So if we look here at, and I'm going to draw a very poor representation of the humerus. Okay? Got a ball on one end, right? And a hinge joint on the bottom, okay? And we all know that it goes down here onto the, you got the radius here and the ulna. The ulna comes around like that, right? Okay, and this is the bicep muscle. Okay? And the bicep muscle has two heads. It attaches on one end to the humerus, right? This is the humerus. And I'll color that muscle red because we typically like to see muscles. You'll see them often shown in red. Okay? The point of attachment of that bicep muscle to the humerus, think about it, when your bicep muscle contracts, does the humerus bone, does that bone move? No. When your bicep muscle contracts, it brings your lower arm up in that flexion motion. So the point of the end of the muscle up here is the origin. And this end down here is the insertion, where you have your muscle movement taking place. So the end of the muscle up, high up on the humerus bone is the origin, and the insertion is down here on the radius because that's where the movement occurs. So movement is achieved when the insertion point is pulled closer to the origin point. No, not the ulna, because you're moving the radius and the ulna up.
The hinge.
Look up there on my diagram, up higher on the humerus. That's the insertion. The origin, I'm sorry. The origin. The insertion is where you have the movement. So they're going to be opposite ends of each other, origin and insertion. So the tricep muscle, which is opposite. So if I draw the tricep muscle back here, its origin is also on the humerus, and its insertion is on the ulna. Because when your tricep muscle contracts, it's bringing it's extending your arm back out. Okay? So this is the tricep muscle. And notice how those motions work in opposition to each other, right? So we call these antagonistic pairs. Antagonistic pairs. Because the pairs work in opposite directions of each other. Because muscles can only do one thing, and that is to pull. They cannot push. So when your bicep muscle is contracting, it's going to be decreasing that angle for flexion. But in order for you to do extension, your tricep muscle has to pull in the opposite direction. Does that make sense?
If we were able to pull, if we could pull, do you think we could have stretchy arms?
In order to have stretchy arms, your bone would also have to lengthen. Are you talking about the Fantastic Four, the dude that...
Would that have to do with your molecular cells?
Well, we have bones that don't stretch, right? And if you overstretch a muscle, what's that called? A pulled muscle. And if you overstretch a muscle, it actually tears. Okay? And it hurts really bad. Okay? You understand origin and insertion? And antagonistic pairs, yes? Okay, this drawing is all going away, but it will be saved forever on this recording. So if you need to see it again, you can just fast forward in the recording and pause me and stop me wherever you want. Okay? So, muscles are going to be working in groups. So the bicep muscle is the main muscle in that group. There are also lots of other different little muscles. Okay, so muscles work in groups. You have the main muscle, which is called the prime mover. And then you have the synergistic muscles that work along with the prime mover. But let's not forget the muscles that work in the opposite direction of what the prime mover is doing, and that's the antagonistic muscle. So for the example we were just talking about, you have the bicep and the tricep. When you're flexing your arm, all the muscles that work along with the bicep muscle are your synergistic muscles. The antagonist to that motion is the tricep muscle. But if I want to extend my arm, now the tricep and all the associated muscles are my synergistic muscles. And my bicep becomes the antagonist. So a muscle isn't just an antagonistic muscle and that's all it is ever. Remember, they have to trade off to achieve movement. All right, moving on. So here's a diagram. They call the agonist is also the synergist, okay? So agonist and the antagonist. So in the first picture there on the left, the bicep is the agonist, okay? And the tricep is the antagonistic muscle. But then you'll see when you're flexing the arm and straightening the arm back out, now the tricep becomes the agonist and the bicep becomes the antagonist. The tricep is a muscle that it's a very weak little muscle. It doesn't, gravity helps a lot too when you straighten your arm back out. So this is why you get those kind of like bat wings as you get older, especially ladies, right? So, and this is one thing about my body that I'm like, oh, I really need to do something about that. Tennis players, however, have really, really nice triceps. Why? Is it the forehand in tennis? It's the backhand. It's all about the backhand. You think about it, every time a tennis player hits a backhand with force, that's using that tricep muscle. And that's not a typical motion we do, is it? No. So the exercises for having strong tricep muscles is you literally have to, pull things straight, where you're constantly extending your arms. So it's just not something that you typically, a motion that you do a whole lot. But you can, just take some cans and you, this is hard to describe, but you point your elbow up towards the sky and you hold the can and you, just like a big can of beans or something, start with one smaller and they get larger and larger. Use it as a weight. You don't have to buy expensive weights. And you just do that motion where you're extending, and you can get rid of your bat wings. I know you guys don't have bat wings yet, but yeah, you will one day. And then you'll be like, oh yeah. And that's to get rid of those muscles. Can of beans, and yeah. Okay, posture. Okay, so right now, become aware of your body position. Are you slouched? Are you looking down? Are you sitting up straight? When I mentioned posture, did you immediately set up? Yeah, probably. Okay, so posture, our posture is maintained by groups of muscles in our core contracting and what we call tonic contractions. And tonic contractions are not where you're flexing a whole bunch of muscles at the same time. It's just small little groups, a few muscle fibers, so just a few muscle cells taking their turns one at a time. And you're not going to have any visible movement, yet your body's going to be able to maintain your posture. Why is posture important? Because it reduces your strain on your muscles, your tendons, your ligaments, and your bones. It allows you to get a good deep breath. More oxygen to your brain prevents fatigue. And of course, bad posture all the time can lead to deformity. And doctors are seeing more and more people coming in with problems with what body part? Their back, their shoulders, and their neck, because we're always staring down at our cell phones. Okay? So, great exercises for your core. You have to remember, your core is not just your abdominal muscles. It's also your back muscles. And our abdominal muscles are super, super important for holding us upright. Okay? So, sit-ups, planking. Okay? And then, they may, I don't even know what it's called. I know it's got some kind of name, but it's like a ball with a platform attached to it where you stand and you have to keep your balance. That's great for posture. Okay? And maintaining those strong core muscles. Just take a deep breath in, flex your abdominals, and feel how it makes your back feel better. So if you're having a low back pain, then flex your abdominals. So in my lecture, we're going to watch a TED Talk, okay, on the benefits of good posture.
Cuando hubo el terremoto, pues, sentimiento de solidaridad aparece. Va a llegar el momento en donde la vida te llama y eres voluntario. Es mi momento.
Sorry, I have to show the commercial.
Has anyone ever told you, stand up straight, or scolded you for slouching at a family dinner? Comments like that might be annoying, but they're not wrong. Your posture, the way you hold your body when you're sitting or standing, is the foundation for every movement your body makes, and can determine how well your body adapts to the stresses on it. These stresses can be things like carrying weight or sitting in an awkward position, and the big one we all experience all day, every day, gravity. If your posture isn't optimal, your muscles have to work harder to keep you upright and balanced. Some muscles will become tight and inflexible. Others will be inhibited. Over time, these dysfunctional adaptations impair your body's ability to deal with the forces on it. Poor posture inflicts extra wear and tear on your joints and ligaments, increases the likelihood of accidents, and makes some organs, like your lungs, less efficient. Researchers have linked poor posture to scoliosis, tension headaches, and back pain, though it isn't the exclusive cause of any of them. Posture can even influence your emotional state and your sensitivity to pain. So there are a lot of reasons to aim for good posture. But it's getting harder these days. Sitting in an awkward position for a long time can promote poor posture, and so can using computers or mobile devices, which encourage you to look downward. Many studies suggest that, on average, posture is getting worse. So what does good posture look like? When you look at the spine from the front or the back, all 33 vertebrae should appear stacked in a straight line. From the side, the spine should have 3 curves, one at your neck, one at your shoulders, and one at the small of your back. You aren't born with this S-shaped spine. Baby spines just have one curve, like a C. The other curves usually develop by 12 to 18 months as the muscles strengthen. These curves help us stay upright and absorb some of the stress from activities like walking and jumping. If they are aligned properly, when you're standing up, you should be able to draw a straight line from a point just in front of your shoulders to behind your hip, to the front of your knee, to a few inches in front of your ankle. This keeps your center of gravity directly over your base of support, which allows you to move efficiently with the least amount of fatigue and muscle strain. If you're sitting, your neck should be vertical, not tilted forward. Your shoulders should be relaxed, with your arms close to your trunk. Your knees should be at a right angle, with your feet flat on the floor. But what if your posture isn't that great? Try redesigning your environment. Adjust your screen so it's at or slightly below eye level. Make sure all parts of your body, like your elbows and wrists, are supported, using ergonomic aids if you need to. Try sleeping on your side with your neck support and with a pillow between your legs. Wear shoes with low heels and good arch support, and use a headset for phone calls. It's also not enough to just have good posture. Keeping your muscles and joints moving is extremely important. In fact, being stationary for long periods with good posture can be worse than regular movement with bad posture. When you do move, move smartly. Keep anything you're carrying close to your body. Backpacks should be in contact with your back, carried symmetrically. If you sit a lot, get up and move around on occasion. And be sure to exercise. Using your muscles will keep them strong enough to support you effectively, on top of all the other benefits to your joints, bones, brain, and heart. And if you're really worried, check with a physical therapist. Because yes, you really should stand up straight.
Okay, so there's lots of benefits to having good posture. Nope, I don't want to go to that. Let's see. Why does it keep doing that? Sorry. All right, so we had some technical difficulties. Here we go. Heat production. This is the third main biggie of skeletal muscle associated with skeletal muscle. So far, everything that we've been looking at has been associated with skeletal muscle. Okay, maintaining your posture, movement, and heat production. Okay, these are the 3 big ones that are associated with skeletal muscle specifically, okay? So we have to maintain a constant body temperature. If you're running a fever, are you at your normal body temperature? No. Okay, your hypothalamus has released chemicals called pyrogens that are increasing your body temperature to make your body an inhospitable environment for a pathogen, something that has invaded your body, making you sick. Okay, so running a fever is often a sign of being sick. If you've ever seen that movie, I've honestly never ever seen it, Osmosis Jones. Okay, Osmosis Jones, I've never shown it to a class and I've never even seen it. So it's not so good. I don't know, maybe it is so good, I've never seen it. But in Osmosis Jones, a virus is trying to get to the hypothalamus, and Osmosis Jones is trying to protect the body. And so, yeah, I don't know the whole thing, but it's all about the hypothalamus is trying to raise the body temperature. Hypothermia is the opposite, right? Hypothermia, your body temperature is below normal. And it doesn't have to go very far below normal. If you're 96 degrees and you're supposed to be 98, if you're 95, 96 degrees, that's hypothermia. Your body will naturally, trying to conserve heat, shunt your blood from your skin, where you'd be losing heat, to your inner core organs. And this is how some people are actually able to survive, like being frozen in a river kind of thing. And they're not frozen solid, but, they warm them up and they actually, take somebody who maybe stopped breathing.
Meredith Grey.
Okay. They've done this with animals, right? They've frozen animals and brought them back. And as far as they know, the animal's okay, but they can't really give an animal an IQ test. Okay? So how do we generate this heat? In order to generate this heat, we have involuntary contractions of our muscle cells. And what do we call this? Shivering.
I have a question.
Question?
You said that the blood stops going to your skin.
Yeah.
And is that how you easily get frostbite? Because
yes.
It's not warming.
Yes, exactly. So you think of your body's going, okay, I don't need to send blood to my fingers.
Or your nose.
Or the tip of your nose, your toes, and things like that, because I want to keep that blood. Because when it sends it out to your fingers are going to get cold faster because there's more surface area per volume, and so your fingers are going to cool off faster. So you'd lose a lot of heat through your fingers, and so those areas of our body are going to be colder. Exactly, and so frostbite is gangrene because the tissue actually dies because of the lack of blood flow. Okay, good connection there. I hadn't thought of that before, but that's a great connection. Okay, so to generate heat, our muscles are going to generate heat every time they contract. And this is how we stay warm, is because of all of those muscle contractions that are going on, even though we are not moving. You guys now understand that even when you're not moving, muscles are contracting in your body. And your skeletal muscles make up 40% of your body mass. So we have excess heat. And this is why when you're exercising, what happens to your surface temperature? You get hot, you get red because you're sending extra blood flow to your skin to radiate that extra heat that you're generating because of all those muscle contractions, and you're sweating to cool your body back down. Okay, now before we go on, there are two other functions that I want to mention that don't have anything to do actually with physical movement. Okay? And I want you to not forget that you have blood flow as another really important function of muscle, right? The heart acts as a pump. To circulate your blood. Okay? Blood flow. And then, last but not least, peristalsis. And that is the contractions of the muscle lining the intestines. We'll call it the gastrointestinal tract. Okay, the muscles that line the gastrointestinal tract. So that would be the movement of stuff from the from the mouth to the esophagus, to the stomach, to the intestines and out. All of that movement is not because of gravity. The movement of food through your digestive tract is due to contractions of smooth muscle. And those contractions are called peristalsis, okay? Peristalsis. So blood flow is made possible by cardiac muscle. Peristalsis is made possible by smooth muscle. So we have, other functions for the muscular system besides just movement and heat production. Okay? So, the last few slides that I'm going to go through, I'm not going to talk about them, but I'll just click through them so that if you're watching this, and it's on the structures that you need to recall of the 3 different types of muscles because we're running out of time here. Okay, again, this is going to get posted onto Google Classroom, and it'll take you to my YouTube page called Zitterkoff Science. Okay, and please like my channel and subscribe to my channel. I have 170 some followers. I'd like to see those numbers go up. So make sure to like and subscribe. I know how to do this thing. You guys might think I'm a boomer, but I'm not. Oh, no, I'm not a boomer. I was born in 1969, and I'm a Gen Xer. So do not call me a boomer. My daughter does, and it pisses me off.
Okay, boomer.
I tell her, oh, no. Gen Xers were the last great generation. After that was the millennials. Okay? You guys aren't millennials. You're Generation Z. You know that, right? Okay. So please make sure you like and subscribe. But the next few pages here are on the different types of muscle tissue. And I'm going to just click through the slides so that you guys will be able to see these, all the information. But you would, of course, pause this because it's going to go faster than you can possibly write. But I'm just trying to get this down. These are our 3 types of muscles. And this is what you would do. This diagram is what you would put on your left-hand page. And then our last type of muscle tissue is our smooth. So we have 3 types of muscle tissue. Okay? And that's it. Leave me a comment below.
Nice.
And yeah, like and comment about my channel below. And let me know what I can do to improve for you guys, all right? And until I record my next lecture, that was 32 minutes and 27 seconds. Bye.
Is it the 13 subscriber one?